Hello students, today we will learn the working principle of optomechanical comparator. Optomechanical comparator, which is also called as mechanical optical comparator. So this is the schematic diagram of the optomechanical or mechanical optical comparator. So here this optomechanical comparator uses two principles for magnifying the readings. So first principle is the mechanical principle. It uses the mechanical lever here to amplify the image or the readings. Then again, this magnified readings will be sent to the optical system. So here the optical system consists of a mirror pivot, a mirror, then there is a projection lens and a glass plate carrying index line, and there is collimator lens and the light source. There is a screen with a scale, so which will reflect back the rays sent from the mechanical lever, which has already magnified the deviation or the readings. So we will learn how this instrument is working. So in this comparator, the small displacements of the measuring plunger are amplified by first by the mechanical lever. So the mechanical lever, this mechanical lever will cause the mirror to tilt about the mirror pivot. So here there is a mirror, and this mechanical lever will make this mirror to tilt about this mirror pivot, and the image of the index is projected on a scale on the inner surface of a green screen. So image of the index, that is the mechanical amplified image, will be projected on a scale on the inner surface of a green screen. So this is the green screen, and this image will be projected here. The mechanical lever, whatever image it is producing, it will get projected on the mirror, and then it will get back to the screen, and the reflections are obtained, and they are then passing through this projection lens, then a glass plate which is carrying the index line, and they are again collimated, that is nothing but they are collected together on the collimated lens, and through the light source we will be able to see the image. So the mechanical lever, so by the lever principle, the mechanical amplification can be written as L2 divided by L1. So this is L2 here, and this is L1, and this is L3, and this is L4. So by mechanical lever amplification, we get will be L2 divided by L1. So if the plunger movement has an effect on turning the mirror by an angle theta, then the reflected ray D will be turned through an angle 2 theta. Therefore, the optical amplification can be written as, so optical amplification can be written as 2 into L4 divided by L3. The overall amplification is the product of both the amplifications, that is 2 into L2 divided by L1 into L4 divided by L3. So this is about the principle of mechanical optical comparator. The example for this type of comparator is ZS ultra optimeter. So this optical system, including in this instrument, has a double reflection of light, and thus it gives higher degree of magnification. So as we can see in this figure, the light or the lamp will send light rays through a green filter. So here there is a green filter, and the light is sending the rays through this filter. So what does it do? It will filter all the rays except the green light, because the green light causes less fatigue to the eye. Then the green light passes through the condenser, which via an index mark projects it on a movable mirror. So there is a condenser. So firstly the green light filters all the rays except the green light, and then it will make it pass through the condenser, which will project the light on the movable mirror. So here M1 is the movable mirror and M2 is the. So after the light falls on the movable mirror, it is then again reflected to another fixed mirror, that is M2, and back again to the first mirror, that is M1. Then the objective lens brings the reflected beam from the movable mirror to a focus on a transparent graticule containing a precise scale, which is viewed by a eyepiece. So this graticule will have a precise scale which will show the readings, and it is viewed through the eyepiece. So the projected image of the index line on the graticule can be adjusted by means of a screw in order to set the initial zero readings. So this projected lines on the graticule, it can be adjusted by means of a screw, so that we have to get a zero reading first. When correctly adjusted, the image of the index line is seen against that of a graticule scale. So the end of the contact plunger rests against the other end of the first movable mirror. So here you can see there is a plunger and it is in contact with the first mirror, that is the first movable mirror. So that if there are any movements of the plunger, there will be vertical movement of the mirror as well. So this will cause the shift in the position of the reflected index on the line of the eyepiece. Okay. So if the plunger moves, this movable mirror will move, and the reflections which are collected at the graticule will have some deviation or displacement. So because of that, there will be change in the readings on the scale. So that will measure the displacement of this plunger. So here a lamp sends light rays. So what are the advantages of these comparators? So these optical comparators have few moving links, and they are not subjected to friction, and that is why there is less wear and tear. So this will result in high accuracy of measurements. And so the scale can be made to move past a datum line and thus have high range of measurement and no parallax error. So the magnification here will be very high. So what are the disadvantages? So the disadvantages of these comparators. So heat from the source of light like transformers may cause the setting to drift. So an electric supply is necessary to operate these type of comparators. So electric supply is necessary. So the size of these comparators is very large and they are costly. Since the scale is projected on a screen, it is necessary to use these instruments in dark rooms so that we will take the readings easily. So, in some comparators in which the scale is viewed through an eyepiece of a microscope are not convenient for continuous use. So, they are not convenient for continuous use.